Hi kids, very good morning. Welcome to our math session. So today the topic we are going to deal with is probability. Now, you may be playing cricket, making yourself into two teams, and one of you yourself among yourself you decide that one team has to go for batting and the other has to go for bowling. How do you decide it? Anyone? Yes, by tossing a coin. We just go for tossing a coin and decide who is going to bat or is going to bowl. Why do we choose this tossing a coin as a fair way of deciding? The reason is the probability of getting a head or a tail are equal chances. So we go for tossing it and choose who is going to decide what. Yes. Now in this experiment we have some mathematical terms to learn in this. So the outcomes, what we are calling it as heads and tails, are called said to be the outcomes. And these two outcomes together, head and tail, is said to be sample space. So here the sample space is denoted by a letter S as head and tail. So these are the two outcomes. And how many elements do we have in this set? This is head and tail together forming a sample space, and this we represent n of s is equal to 2. Sample space, how many heads do we have? We have one head. So here n of h is only 1 and n of tails is also 1. Now, pause. The probability of the event H, how do we calculate? What is the probability of H? So here we write down probability of getting a head is number of favorable chances by total number of outcomes. That is, we have only one out of total 2. So the probability of getting head is 1 out of 2. Similarly, for probability of tail is said to be 1 out of 2. So this is said to be the probability of head as well as tails. Next, is this going to be a fair event? Yes, it is going to be a fair event when we toss a coin, because the probability of getting head is 1 by 2 and probability of getting tail is also 1 by 2. So both the teams have equal chances of winning it. So this is called a fair way of deciding which team has to bat or bowl. Coming to the next concept. Suppose a coin what you have chosen, if both sides are kept the same event, like we have seen Muqaddar Ka Sikandar, where the actor says that both sides he keeps the same tail. So that coin, if you are tossing it, it is very sure that you are going to get tail whatever way it falls down. So that tail is said to be a sure event. So here if you take that type of coins, so the probability of getting a sure event is said to be 1. And the probability of, because both the coins are set fixed as tails by making it a biased coin, and what is the probability of getting a head in such cases? So it will be 0, because there is no chance of coming head because both the sides are having tails. So the probability of an impossible event is going to be 0. And next, we have a small equation in probability that the probability of head plus probability of not getting a head is equal to 1. Let us take another experiment of tossing two coins at once. When you are tossing two coins at once, what are the outcomes and what is the probability of each event we'll discuss in this experiment. Now, before going to this, first I'll go for first coin. What are the outcomes if you are tossing a coin once? It is going to be heads or tails. And the probability of a head is going to be 1 by 2, as I've explained you before. And next, the probability of getting tail is also 1 by 2. So this first coin is done. Next, With the second coin, when I toss it, it may be head or tail. So what we do here is again head, this is for the second toss, or tail, and the other one also, here also we get heads or tails. Here also the probability is 1 by 2, 1 by 2, and here also it's 1 by 2 and 1 by 2. Now, what are the outcomes when we are tossing two coins at a time? So here we write the sample space for this as head, 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 tail, tail, head, and tail, tail. So this, all four of them together form sample space. So here the sample space is given as head, 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 tail, tail, head, and tail, tail. Now, in this, now we have questions based on this. What is the probability of getting any event? Before going to that, how many events do we have in this? 1, 2, 3, and 4. So the n of s is equal to 4. Now, after writing this, now we can ask for what is the probability of getting both heads. How many heads we have in this? 4. Only 1. So the chances of getting this event is 1 of total 4. Similarly, for tail, tail it's also 1 by 4. And suppose if I change the question in other way, what is the probability of getting one head? What is the probability of getting one head? So when I say one head, here 2 heads rejected, 0 heads rejected. So one head is here and one head is here. So here, how many are there? How many events are there? Favorable outcomes for this one head. Head, tail, tail, head. So there are totally 2 out of total 4. So the probability of getting one head in this event is going to be 2 by 4, which is said to be 1 by 2. Chapter, what all we have observed? We have observed that probability of impossible event was 0 and the probability of a sure event was 1. So here, and the probability of head, something was 1 by 2, 1 by 4, etc., etc., etc. By seeing all these values, what do you understand? The probability of any event can be either 0 or between 0 and 1. So it cannot be more than 1 or less than 0. So what do you mean by that? The probability of any event cannot be negative or cannot be more than 1. So this is the total concept of probability based on tossing a coin. Now let us go for another experiment, the last concept for the class. Let us go for an experiment of tossing a dice. So it's a cube. How many faces a cube has? 6 faces. So here every face is marked with one number 1, 2, 3, 4, 5 and 6. So in this case, the sample space for this experiment will be 1 can come, 2 can come, 3 can come, 4 can come, 5 and 6. So these are the outcomes when we are dealing with the dice in this experiment. So the sample space will be 1, 2, 3, 4, 5 and 6. So in this, what is the probability of finding any event? Before going to that, what do we need to write? How many terms do we have? How many elements do we have in this sample space? 1, 2, 3, 4, 5, 6. So the number of elements in this n of s will be 6. So next comes the next one. What is the probability of getting 1? We have only 1. So 1 by 6. What is the probability of getting 2? 1 by 6. What is the probability of getting any other number? It's always again the same, 1 by 6. So the probability of getting each element or 1 or 2 or 3 or 4 or 5 or 6 is the same. So tossing a dice is taken as a fair deal or a fair experiment. So here tossing a dice and coming out outcomes can be taken as a fair deal. Next, what is the probability of getting an even number? What is the probability of getting an even number? How many even numbers do we have? 2, 4 and 6. 2, 4 and 6. So there are 3 of total outcome 6. So it's going to be 1 by 2. So the probability of getting an even number is 1 by 2. Next, using this, what is the probability of getting a non-even number? Not an even number. So what do we do? Sum of all the probability is going to be 1. So 1 minus this probability will give you 1 by 2. So the probability of getting an even number is 1 by 2. The probability of getting a not an even number, or another way, odd number, is also 1 by 2. And if you see this, the sum of the probabilities is 1.